as we continue here, we notice that these two rows that we have in this augmented matrix are identical. So, well, that's going to indicate at some point that the null space is non-trivial. But let's continue with the calculations and see what they lead us. So to keep reducing this, I'll have that to row 1, I will subtract twice row 2, and to row 3, I will subtract row 2. And after that, we'll see the following reduction. It's 1, 0, 2 times 2 is 4, so this one becomes -1. This one stays as 0. This one stays as the same row, so this would be 0, 1, 2, 0. And this one will become 0, 0, 0, 0. And boom, well, we're done with the reduction because now this one is in row reduced echelon form. So now let's read off what the system originally started with now indicates. So this says that if I have a vector x1, x2, x3 that belongs to the null space of T, then, well, x1 minus x3 is equal to 0. X2 minus twice x3 is equal to 0. And x3 is equal to x3. Well, there's nothing to be done here. But out of the system, we obtain one that is equivalent, which says this. x1 is equal to x3. x2 is equal to 2x3. And x3 is equal to x3. Oh, so if we have a vector that belongs to the null space, we can decompose it in the following way. First, x1, x2, x3 as the following. X3, 2x3, x3. Factoring out 1, 2, 1. Oh, so what is it saying is that if I have a vector that belongs to the null space, it can be represented as a scalar times this vector. So a basis for the null space of T is given by the set that contains the vector 1, 2, 1. Well, what is this saying? So the dimension of the null space of T is equal to 1. In other words, the nullity of T is 1.